Hey, Miss Weatherall here. I'm going to simplify some radicals using variables just to give you a few more practice problems before you actually try solving it. So what I'm going to do here, I didn't mean to put the equals, I'm going to look for a perfect square. Remember, perfect squares are like 9, 16, 25, so on and so forth. So I'm going to try to find those. So what I'm going to do is my calculator, I'm going to put like 384, and it's a big number, so I might start with the number 121, which is 11 squared. And if that didn't work, which it doesn't, I would try the 81, which is 9 squared. So 384 divided by 81, and that doesn't work. So what I eventually find out by trying those on my calculator is that this breaks down to 64 and 6. 64 is 8 squared. So what I'm doing first is my numbers, and the square root of 64 is 8. So my number is 8, and I'm left with a radical 6. Now let's take a look at the x. Remember, the x can be written like this 3 times. And if I don't see the index, I know that there's a 2 there. So you circle pairs of 2, and all I have is one pair. So you bring one x outside, you bring your one pair outside, and then you leave in the radical 1x. So combining the two that we just did, you're going to have 8 on the outside, x on the outside, and then on the inside is your 6 and your x. So you've simplified it with variables. I'm focusing more on the variables than showing you the process of getting the numbers, because I did that in the previous video. So let me try number 5 with you. It's a little bit different because I have that outside number. So for right now, I'm just going to kind of ignore that, and I'm going to focus on the 448. So again, I would try perfect squares that would go in there, 144, 121, 81, so on and so forth, and I would find that this would be 64 and 7. So I'm just doing the number now. This is the 8, and I have a radical 7. Now what's left is my x. Remember, there's a 2 here if I don't see it. I cannot circle any 2's. There's only 1. So that means that that has to stay inside. So your answer is going to be your 8 on the outside times the original number that was there. So times a negative 3. So these outside numbers, you multiply. And then you're left with your x inside, your 7x inside. And then you multiply to get 8 times negative 3 is negative 24. And then inside is your 7x. Okay. So moving on to number, let me do number 7 here. Okay. So again, I have an outside number here, so right now I'm going to ignore that. And I'm going to find the perfect square that goes into 252, if there is one. And after I played with the numbers, I did my work ahead of time, I found that 36 goes into 252 7 times. I did that because the square root of 36 is 6, and then I have a radical 7 still. So now that my number is done, I'm going to look at my x's again. So I'm going to show you another way besides this x3. For those of you who don't want to write this out. Remember, there's 2 here. I circled one pair. So 1 comes out, 1 stays in. Another way to do your x3, so I'm trying to simplify x, the square root of x3, is to take that, take your exponent 3 as your numerator, your index as your denominator, and ask how many times will 2 go into 3 evenly? And the answer is 1. And then how many are left? 2 goes into 3 one time with 1 remaining. So notice you get the same answer. Whichever way works for you is better. So now let's combine. I've got a 6 outside and a 6 outside. I'm going to multiply these two numbers, and then I'm going to bring over my x, and then inside is an x. So there's your final answer for that. Isn't this fun? I know you're having fun. Oops, I forgot my 7x, sorry. And then let me do one more, number 11, because this has more of the variables. And actually, I'm just going to cross the numbers out so I can focus on the variables for this example. So I'm going to look at simplifying the variables inside. So remember, there's a number 2 here if you do not see it. So looking at this example, I can either write m 4 times, p 2 times, q 2 times, so this is way 1, or I can write it as m, take my exponent of 4 and my index of 2, so m 4 over 2, p 2 over 2, q 2 over 2. Whichever way works for you. So the first way, I'm going to make it in purple. Remember, there's an index of 2 if you don't see it, so I'm going to circle the pairs of 2. How many pairs do I have? I have 2 pairs, so 2 m's are going to come out because I have 2 pairs inside. Looking at the p's, I'll do that one in red. I've got a pair of p's. How many pairs do I have? 1, so 1 p comes out of the radical. Q, how many pairs do I have? 1, so 1 comes out of the radical. So these variables would be outside of your radical. To do it the other way here, the m using your exponents or your fractions, your exponent fractions, yeah, there we go. So you ask yourself, how many times does 2 go into 4? You say 2, so 2 m's are going to come out. For the p, how many times does 2 go into 2? 1. And remember, I don't have to have that 1 there, but I'll leave it there for right now. And then my q, 2 divided by 2, how many times does 2 go into 1? 2 times. So again, you get the same answer. So whichever way works for best for you, I want you to use that.